Hi everybody. So at the beginning of this course, if you remember, which now felt like, I don't know, centuries ago, I told you that I tried to construct this course by talking about the application of each method or tools, and then we're going to learn how those tools works and some computations behind the tools. And then finally, I said that I'm going to introduce you some coding experience in Python so you know how a method works and then you know how to apply it in a computer programming. But then in the past weeks, you've seen that I mostly just talk about the applications of the methods and the methods itself, but we didn't really do any practice at all. So this week I decided to do kind of two practice sessions. The first practice session is to apply word2vec. And then the data set that we have here is a customer review from Yelp website. And then the review itself is kind of mixed. Some reviews are talking about the accommodations, like a hotel or something. And then some other reviews in that data set talk about food. So that's why I here put the picture of like a hotel room and a burger, because that's what the data set, the reviews in the data set are talking about. Okay, so let's start. To be able to follow the examples in the session, you will need to install these two packages. The first is called Gensim and the other is called Pandas. The environment that I use is called PyCharm, and then the Python version is 3.7. If you fail to install one of the packages, sometimes the reason is this Python version. Some packages are no longer working in Python version 2. Let's start with a very small example here. So in the first line, I simply say that I'm importing the Gensim package. And then on the third line, I created the input that is required by Gensim word2vec. The Gensim word2vec requires a list, and then within the list, you have each sentence also in its own list. So you see that here I have two lists, and each list is a sentence. And then within each of this smaller list, I need to break down each word into its own word separately. So the first sentence is broken down into this is the first sentence. So that's the elements of the first list. Same thing for the second list. So if you have a string, this is the first sentence, you have this string, and then you want to break it down into this kind of list, you can use the split function. The split function will split the string into each word separately in a list. And that's what is required by the Gensim word2vec. And then once you have that kind of format, remember that you need to have this format. Otherwise, the Gensim word2vec will not work, or it will work but gives you the wrong result. Okay. Once you have that list of lists, you can put it into creating a word2vec model. So on line 6, I said that the model is called by this command gensim.models.word2vec, and then I put the list of lists into this command. And then also there are some behaviors that you would like Gensim to consider, and those things can be specified using these parameters. Now I will talk about these parameters in the next slide, but suppose you're not specifying any parameters here. It means that word2vec Gensim will just use the default parameters. It will run, but then if you need to specify some specific things that you would like to have in the model, then they will just use the default values. Now let's take a look at each of the parameters one by one and then see when you need to specify these parameters. Okay, so the first parameter is size. It will determine how long your embedding vector is. Remember that word2vec is embedding words into vectors, and then here you specify how long your vectors you would like to be. For example, here when I say 13, it means that each word will now be represented by a vector of 13 elements, 13 real number elements in a vector. So if you don't specify the number, the default is 100. Means that the Gensim word2vec will create a vector of the length 100, and those vectors will represent the words. The next parameter is window. If you remember, this is the sliding window. So you have the target word, and then you slide the windows several words to the left and several words to the right. So here I specify that the window is 2. It means that if you are at a target word position, you will look at 2 words to the left and 2 words to the right as the context words. And then if you don't specify anything, the default for this window is 5. Next, you can also say that you would only consider words that appear frequently enough. So here I said I set this very low because our example is contains only 2 sentences. So I just set the minimum frequency is 1, minimum count. Otherwise, if your corpus is big enough, you can set this minimum count as 5 as the default, or even greater, right? The reasoning is because if a word appears very rarely, like you have 100,000 of sentences, and then a word just appears once or twice, probably you want to discard them. They will not mean anything, or they will not mean too much on the analysis. Okay, and then next we have the parameter sg. Here I set the sg equals 1, which means that I'm going to use the skip gram model, which is introduced in the word2vec video if you have watched that video. Otherwise, if not, it will use another kind of model to do the word2vec. It's called the continuous bag of words model. Which one is better? Well, it's hard to say. Sometimes it works better for this data set and those sets of parameters, but it works worse for the other data set or the other sets of parameters. So these parameters are quite hard to tune, so you really need to do trial and error to find the best parameters. And finally is the seed parameter. If you do not specify this parameter, every time you run this code or this program, you will get a slightly different result. But suppose you want to get the same vector exactly anytime you run this code, you need to specify that the random seed number that you use is a particular number. For example, here I specify the seed is 10. So every time I run this model, rerunning this code, reloading this code, the vector will always be the same. Okay, because I use the same random number seed. So those are the parameters. If you want to specify, you need to specify them. Otherwise, you can just leave them to the default values. Now let's see some results here. So on the line 15, I just print the vector for the word the. So this is how to call the vector. So you type model, and then you use bracket, and then put the word that you would like to see the vector. Okay, you should see a vector with dimension 13, because remember I put the parameters 13 for the size. And then on line 18, I simply print out the most similar words to the word the. This is how you call the comment model.wv.most similar, and then in the parentheses you write down the word the. This will return the top 10 most similar words to the, as well as the cosine similarities. The higher the cosine similarity is, the more similar the word that, the more similar a pair of word is. But here, if your vocabulary size is less than 10, I think in this example I have less than 10 words, then it will give you less than 10 most similar words. Okay, but the default is it will return top 10 most similar words and the cosine similarity. And then on line 20, I just simply print out each word in those top 10 most similar words. I print out each word and then its corresponding cosine similarity, just to make it easier to read. We'll see these results in the next slide. Now let's look at the results. So the first result is that you should see the vector that represents the word the. It's the vector of dimension 13, because I specified the size of the vector is 13, if you remember in the previous code. And then next, you will see top 10 most similar words to the word the. And then you see here, each element in this list is a tuple. So tuple in Python is something that is inside this parenthesis. And then here, the first element in the tuple is the word. The second element in this tuple is the cosine similarity between this word and the word the. Here, I just printed out those top 10 most similar words to the word the. So the word that is most similar to the word the is this, followed by words are, this, and so on. So for example, the word in and the word the has the cosine similarity of minus 0.35. So if this result looks a bit weird, like you think the word the and this shouldn't be very similar, and also the similarity are quite low actually, because the similarity should range between -1 and 1, but here you see the similarity is a bit low. Can you guess why this result looks weird? Like first, why the top most similar word is not really similar, like the and this, they're not very similar. And then second, also why the similarity are kind of low. Can you guess why this happens? Now let's move on to a larger example, so hopefully the result would make more sense. So the CSV data is in this file, and then I've already uploaded this on IDE, so you can just go to the IDE and then upload this CSV dataset. So in this code, in this first and second line, I simply import the required packages, Gensim and pandas. And then on line 5th, I just read the CSV data into a pandas data frame, and then I named the data frame as df data. So you should change this directory into the directory on your laptop or computer where you store this file, okay? So this is where I store my file on my laptop. So you need to change it according to your directory on your laptop. And then on line 8, here I drop the lines from the dataset which contains empty review. If you do not drop that lines, the data frame in pandas will read those lines as NaN, not a number. And then it will kind of mess up the computation later. So here I just drop the lines which contains the NaN, not the number. And then here on the line 11, I just truncate my data frame after the line 999, which means that I only keep the first 1,000 lines from my dataset. You may keep the entire 10,000 data, but it will make your word2vec run slower. So here I just want to have the result quickly. So I just truncate the dataset into the dataset that only contains the first 1,000 lines. So I just take the data from the line 0 to line 999 and then delete everything after that. Okay, if your word2vec still runs very slowly, you may truncate this dataset further. But of course, if you have smaller dataset, your result in word2vec will make less sense. Okay, so if you want to have the result that makes more sense, of course you need more sentences. Now you have the data frame, but you want to convert it into the input that is required by the Gensim word2vec. So what I did here is that first on line 14, I just called the column review list from the data frame. So this review list is the name of the column in the data frame df data. And then I convert it into a Python list. But if you remember that for running the Gensim word2vec, you need to have each sentence in a list, and then each word in the sentence is broken into its own separately. So that's what I did on line 16 here. I use what is called as a list comprehension. So what I did here is that for each review in ref list that I have before, I will split each of those review such that now the sentence list will contain each sentence in a list, and then within that list each word in the sentence is broken separately, which is what the Gensim word2vec wants. By the way, there's an assumption here in this data set is that each review is considered as one sentence. So if you look at the data set, each review is just a long list of words, and then it does not have a period on it. So for this example, I just assume that one review equals one sentence. It is not correct. It's not totally correct, but then I think it's fine just to look at this example, okay? So that is the assumption here. One review equals one sentence. So in the sentence list, each smaller list in this big list is actually one review, but I assume it as one sentence, okay? What if your data set contains, in a review, contains a lot of sentences? Well, as I shown before, the word2vec Gensim, it requires you to separate each sentence into a list and then separate each word in that sentence into its own separately. So here I just showed that each element in the sentence list is a list, and then within each list you have each word separated from the others. Okay, so this is what the Gensim word2vec once for the input. Here I'm using the try except function. The reason is because running word2vec sometimes takes a very long time. I remember while I was doing my PhD research, sometimes I just left the word2vec running on my PCs. So I have two PC computers in my lab, and then I ran this word2vec and the other text mining stuffs on both computers. So you can imagine that I used two computers and then I left them running overnight. And then I came back in the next day, and sometimes I got the results already, sometimes they were still running, and I was like, oh wow. So I can totally understand if it takes a long time in your laptop to run. So like I said before, you may cut the data set so you have a smaller number of sentences, so at least you get the result and you can see it. So for the hardware issues, maybe if the condition becomes better and then you get a better computer on campus so that you can apply this tool for a larger data set. Okay, but if you just want to try to apply it to a data set, just make the data set smaller. That's the first tip. And the second tip is use this try except. So here in the try part, line 18, I simply try to load a word2vec model. So I try to load it. So the Python will check, has this model been available? So it's trying to check this. If it is, then okay, I just load the model and I do not rerun the creating the word2vec model. However, if Python does not find any of this model, it will go to the except part. So in the except part, just as before, we are creating the word2vec model. So you put the sentence list from the previous slide. I specified that the length of the vector is 50. I use the window is 3, so looking at the words 3 to the left and 3 to the right. Minimum count is 10, so any words that appears less than 10 times in the entire dataset will be discarded. And then I use the skip gram model. Once this model has been created, I save the model. So this is a very important step if you do not want to keep rerunning this word2vec model. If you don't save it, it means that the next time if you're closing your PyCharm and then you reopen your PyCharm, it means that you have to rerun the word2vec model, which let me assure you that you do not want to do that, especially if your data is large. It may take a day or more, and then you need to just keep waiting for that. So I strongly suggest you to, anytime after you create a word2vec model, save it. So next time you reopen your PyCharm, you can just conveniently load that model. Okay. So that's how I use the try except function to keep my word2vec model. Now let's see some results. Here I just specify 3 words that I'm interested in. So I have the query word food, I have the compare word 1 car, and compare word 2 delicious. So as usual, first I just try to display the vector. Here I'm displaying the vector for the word food. So you should see a vector with dimension 50, because I specified in the model that the size is 50. So you should see the vector with dimension 50 that represents the word food. And then I also print out the most similar words to the word food, because this query word is food. So I display top 10 most similar words to the word food. and it will be sorted by the cosine similarity, as you've seen before in the small example. Now finally, something that I have not done in the smaller example, I compare how similar two words are. So here on the line 39, I check the similarity between the query word food and the compare word one. So you should see the cosine similarity between food and car. And then the result from line 40 is that you should see the cosine similarity between the word food and the word delicious. So when I run this program, the result makes sense, which means that the cosine similarity between food and delicious is higher than between food and car. If you run this code, but with a different data set, let's say you only consider 50 sentences, or let's say you change the parameters, the result might be different. So don't be too surprised or shocked if you look at the result and you see that, wow, food and car is more similar than food and delicious. How can that happen? Well, that can happen, let me show you. So if you change the parameter of, or if your sentences are, you have a small number of sentences, that kind of strange result may happen. Now let me give you some questions to reflect on. So the data seems to contain reviews for both accommodations and eateries. So like I said in the beginning, I put the picture of a hotel room and a burger. If you look at the data set, it contains this kind of reviews. So the one is talking about a motel, and then the other is talking about burgers. So we have a data set that talks about accommodations, restaurants, food, and everything. Now I want you to think about what will be the effects on the vectors that word2vec learn. What would be the effect if our data set looks like this? Some sentences talk about motels, some sentences talk about burgers, restaurants, and so on. Especially considering that we actually don't have that many sentences. So 1,000 sentences is kind of small in the text mining domain. Even 10,000 is kind of small actually. So we have a small number of sentences, and then furthermore in that small number of sentences, they are coming from, we can say, different topics or different domains. Some about the hotels, some about the restaurants. What would be the effects on the vectors that we learn? Okay, so that's the first question. The second question is that here we assume that one review equals one sentence. So one review which should actually contain a lot of sentences. Here we just assume the entire paragraph of the review equals one sentence. Now can you think about what the effects would be for the vectors that word2vec learn? So these are two questions that you can try to think about, and then you can also look at the results from your word2vec code, check out the similarity between words that you think should be similar, or the similarities between words that you think should be dissimilar. And after looking at those things, you try to think about these questions. And then as usual, if you like to get some bonus points, I will give some bonus points to 10 people who first answer these two questions. You can send your answers to IDE, and then I will look at your answers. If they sound reasonable, then I will give you the bonus point. Okay. So that's the end of the first practice session on using Gensim word2vec. As usual, I hope that if you have any questions, you can just leave your questions in the comment section, or you go to IDE and then put your questions in the Q&A forum. Thank you.